Access control lists, or ACLs, are utilized to identify IP addresses and ports for subnets or hosts. So I can match subnet 164/24 going anywhere, or I can match host 164.0.1 accessing anything on port 80, or I could match 100.64.0.1 sourced from TCP port 5231 going to host 165.65.1 on TCP port 443. I can get quite granular if I need to. While they can be used for filtering traffic on interfaces, they have many more uses. They can be used for matching traffic for QoS or used for route filtering in dynamic protocols. When using ACLs for interface filtering, directionality is very important. An ACL is applied to an interface using either the keyword in or out. The way I remember which is to pretend I'm the router with my hands being the interfaces. For example, if my right hand is the interface I want to do the filtering on, I'll tell myself if I catch it in my hand, the interface, then use the in keyword. If the traffic is leaving through my right hand away from me, then I use the out keyword. ACLs are lists of one or more entries processed from top to bottom. Each entry has one of two actions, either permit or deny. Permit means allow and deny means, deny. ACLs come in several types: standard numbered, extended numbered, and named ACLs. A numbered ACL is one that is referenced solely by a number, whereas a named ACL is one that is represented by an ASCII name. I generally prefer named wherever possible, as their purpose is more apparent based on their name. I'm going to start with the simplest and oldest form of ACL, the standard numbered ACL. When I hear standard, I remember that only the source address is matched. And when I hear numbered, I remember that it is represented as a number from 1 to 99 or 1300 to 1999. Take this diagram for example. I want to block 164.0.0/24, allow host 164.0.2, and allow all other 164.0.0/16 devices as they enter gig 01 of router 2. That means I'll create the list as follows. Allow 164.0.2 first, then block the /24 subnet, and last, allow all other 164 subnets. Keep in mind that ACLs are processed from the top down, and as soon as they match either a permit or deny, processing stops. So order of operation is extremely important. Since these subnets will be coming into the interface, I would add the ACL in the in direction on gig 01. As host A sends a packet, it will start processing in the filter ACL, and as it hits line 1, it will be permitted, and thus allowed. Host B now sends and is denied by line 2 of the ACL. Last, host C sends and is allowed via line 3 of the ACL. Now what happens when host D sends a packet? Since its IP address doesn't get matched by any of the statements, it's dropped. By default, at the end of all Cisco ACLs, there is an implicit deny all. I can't state how important this fact is. If I want to deny a single user via an ACL, and I only put that one deny statement in, I'm effectively blocking all traffic due to the implicit deny any at the end. This can be changed by adding an allow any at the end if desired. Standard numbered ACL's format is pretty simple. It starts with access list, the number to be used, permit or deny, then the matching source subnet info. I'll demonstrate adding the first rule, but I like to begin my ACLs with a description. Config T, access list, 1, remark, user, subs, filter. The remark keyword allows a text descriptor which can be invaluable. Matching a single host is done as access list 1 permit host 100.64.0.2. On newer systems, the host keyword can be omitted, and in fact, if you add it while typing, the command will simply remove it once entered. ACLs have enormous power and are used regularly throughout iOS, so I'd expect to see several questions about them on the test.